Hi, I am Samik Dhar and I will be solving question number 1 of homework 6. So, what do we have in question number 1? So, we have been given x comma y, x and y, and the joint density function of xy as 1 plus xy by a, and mod x for mod x and mod y is less than 1 and it is 0 otherwise. So we need to find a, then we need to find the correlation between x and y and the independence of x and y, then the joint density function of x square and y square, and we need to find the independence of x square and y square. Okay, so for the first part, for the joint density function to be a valid density function, the integral over its entire range should be equals to 1. So after putting the values of x and y from -1 to 1, we find that a is equals to 4. So the value of a is 4 for the joint density function of x and y to be a valid density function. So now, for the second part, we need to find the correlation between x and y. So first, we will find the expectation of xy. It comes around 1 by 9. Then the expectation of x, it comes to be 0. Similarly, how we have found the expectation of x, we find the expectation of y also to be 0. Now the covariance of between two random variables xy can be defined as the expectation of xy minus the expectation of x, expectation of y. So the covariance comes to be 1 by 9. Since covariance is not equals to 0, x and y are correlated. Okay, so x and y are correlated. Now, from second, since x and y are correlated, there is no chance that x and y can be independent. So x and y are not independent. Now we need to find the joint density function of x square and y square. So we can use the transformation method. What is transformation? It's a simple method where we can just assume x square and y square to be z and w respectively. Okay. Then we find the Jacobian. Jacobian as del z by del x, del z by del y, del w by del x, del w by del y. It comes to be 4xy. Okay. Now, so by fundamental theorem, we can find the joint density function of FCW. So what are the roots? Roots are root z, root w, root c minus root w, minus root z, root w, and minus root c minus root w. So replacing it everything in the joint density function. Okay, so it comes to be 1 by 4 root z root w. So now we can replace z by x square and y square and w by y square. So what it comes to, the joint density function of x square and y square is 1 over 4xy. So in overall, we can define the joint density function of FZW as 1 over 4 root z root w, where z is greater than 1 and w is also greater than 1, and it is 0 otherwise. For the last part, we need to find the independence of x square and y square. So if x square and y square are independent, then the density functions would be the product of the individual density function of x square and y square. So then what's the density function of z? As z is x square. So similarly, so density function of z is root z by 2, and the density is function of w is root w by 2. So we can see that the product of this individual density function is not equals to the joint density function which we have been given, which we found earlier. So we can conclude and say that x square and y square are not independent.